Yeah, hi, good morning, friend. Hope everyone doing well, or good afternoon, friends. So today topic is GPU. These days, I have noticed everyone people are running for GPU. You know that any AI acceleration we need any CPU. Everyone asking GPU, and you know the NVIDIA is the mainly provider for GPU, which I noticed. So today let's discuss what is GPU and how GPU is better than CPU. Later we also discuss the TPU, which is the very latest terminology which is introduced by the Google. So what is GPU and how GPU is better than CPU? So first, the GPU full form is a graphic processing unit. GPU is a specialized processor originally designed to render images and video. Today, it is used for the beyond graphic, powering AI, scientific simulations, and the data processing. So, I think, guys, after reading this definition, you are very much clear why GPU is popular these days because these days everyone want to make videos, graphic, images. So we need a strong processor. So that's why GPU is famous. But we need to go more detail that how this GPU architecture is. But we need to understand the CPU also. So let we can first make the difference between understand the difference between CPU and GPU. So these are the table which is showing on the screen where we have mentioned the features GPU and CPU. Whether if I am talking about the cores, you know, in CPU we have maximum 4 to 32 core powerful core. Where in GPU you see the number from 1000 to 16,000 plus small cores means this is the biggest difference. You can see the core processor and best at we need to understand where the CPU is best and GPU is best because we can't use the GPU, you know, where we need a CPU. Means CPU basically need for the end user machine or complex or sequential logic where we can say one machine, one terminology, but where the GPU need, where we have repeated parallel work and parallel mathematics, we need to do parallelly work. So if I'm talking about the speed per task, very fast per core. Per core, you know that CPU is a per core, then very fast. But in that the quite surprising thing in the GPU is per core GPU is very slow. Later we can see the architecture also, but you know it's a myth that you know GPU. That's so I believe everyone say GPU. Maybe everyone come with this myth that you know GPU per processor is very fast, but it is a very important thing we need to understand. GPU per core is slower. Memory, if I'm talking my memory, CPU has a large cache and low latency, but other side GPU has a high bandwidth. If I am talking about the analogy which mostly people are speaking, a few expert professors, thousand. If I will ask that you know the CPU is a few expert professor, yani that some are few people who want to do some typical task, but in GPU, thousand of students working in parallel, thousand of students working in parallel. So this is the major difference between GPU and CPU. We go further. Let's see the core difference how they process tasks. If I'm talking about the CPU normally everyone know that who know the computer is central processing unit where core 1 is doing complex logic, core 2 is doing complex logic, core 3, core 4. So it is same from 4 to 32 powerful cores sequentially. We can say that branchy task they can do. But what about this GPU? GPU find the GPU find the graphical processing unit. Thousands more. You know, this diagram will show the thousand more. This is thousand more. But see the number of 1000 to 60,000 small tasks, parallelly repeated tasks is expert. So GPU doing this thing is expert. Let's go further. So we need to understand where GPU beats CPU. The GPU wins when you break a small problem into thousands of identical subtasks running at once. A rendering graphic, every pixel on your screen need a color calculation. A GPU handle million at once. If I'm talking about the AI and deep learning, training a neural network means multiplying huge metric millions of times. GPU do this extremely efficiently because there are thousands of cores are working doing the same work. If video encoding and decoding, processing each frame of a video is a parallel job, so GPU always win over the CPU in this. Scientific simulation, fluid dynamic, weather modeling, physics engine, all the benefit of parallel. This all the example of parallel number crunching. So GPU win on this. If I am talk, we can need to understand why GPU has some special features. So we need to understand what is inside the GPU chip, because the GPU chip is NVIDIA is the, I think, the biggest provider for GPU chip, and they are charging huge amounts. I have read one news that last month they increased the charges because they, I believe, they have the monopoly. I'm not aware about other vendor, but I know about the NVIDIA has some type of monopoly. So where in GPU chip we have host interface, which is PCI linked to CPU. Where another thing is command processor. From host interface, we are going to command processor where dispatched work to GPC. So now we have different type of GPC. Where the GPC 1, GPC 2. GPC is graphic processor cluster. So we are talking about the clusters now. So what is the role of GPC 1 cluster and GPC 2 cluster? Both are same, but they are dividing the cluster to get more strong output from each parallel working. So, but why we need to understand? Because when you are configuring this GPC, you should know about which CPU processor you are going to buy to save some cost for the company. Where the SM stands for streaming multiprocessor. Streaming multiprocessor cover CUDA cores, FP32 init units, where the wrap schedulers issue at 32 thread. We can discover CUDA core also, where the share memory of L1 cache. The same with the cluster with the other cluster also, where I am talking about the CUDA cores and the wrap schedulers. Like see the block. Each block has the same feature. Each block has the same zipper. So such GPU cluster, we have thousands of clusters, so that our GPU will work more efficient way what output we are expecting. Where we have L2 cache, where the L2 cache is shared across all the GPC. If it is GPC 2, 3, 4, 5, it will share. But the one good thing is a VRAM, which is called a video RAM. GDDR HBM high bandwidth, but this RAM is inbuilt the chip. Earlier, what happened now in CPU side, what you see that you need to add additional RAM, DDR3, DDR4, DDR5. But here, what is this VRAM is integrated inside the chip. It will make more fruitful while getting the results. So the layer of GPU architecture, see that host interface connect to GPU to the CPU over PCI. When you program launches a GPU task, it's inside the kernel. The CPU send command through this link. Command processor receive those command and distribute work across the GPU parallel compute clusters. What is now, see the GPC graphic processing cluster is the top level of grouping of compute resources. A modern GPU has 4 to 12 GPC. A modern GPU, the latest one, it is mentioned that we have 4 to 12 GPC like that, each acting like a mini GPU inside the chip. So this is chip, mini GPU inside the chip. SM is a streaming multiple processor. The job of SM is the fundamental to compute unit. Each SM contain, so each streaming multiprocessor contain what? CUDA core. Hundred of small arithmetic unit that perform floating point and inner math. So CUDA core is playing very vital role inside the GPC 1, where they are doing hundred of arithmetic units. Another one is a wrap scheduler. A is a group of 32 thread. So this is a wrap scheduler where the 32 thread that execute the same instruction simultaneously, the schedule issue wrap every clock cycle. And when one wrap is waiting on the memory, it swap it other another instantly. This is how GPU high memory latency. So that this is the main they did when any see this is a very critical point. I think you need to understand this that the scheduler issue warm every close cycle, and when one wrap is waiting for memory, if one wrap is waiting, it swap to another, it swap to another. So this is the reason that high latency. Okay, let's come to share memory or L1 cache. Ultra fast on the chip memory that all thread in a block can share. This of it as a SM scratched. So it's coming as a SM scrapped. Okay, what is L2 cache? L2 cache sit between SM and VRAM shared across all the GPC. It dramatically reduce how often the GPU has to fetch data from slow VRAM. So let's understand the VRAM which we discussed. VRAM is a GPU dedicated high-speed memory where the GDDR or HBM model GPU have 8 to 80 gig of VRAM with bandwidth exceeding 1 TB, far faster regular system RAM, which is why the large AI model must be fit in the VRAM. So this is the internal layer of GPU architecture. Let I will go further on this video. What is TPU? I heard that TPU is the Google is making TPU, so you are able to screen. The TPU is a tensor processing unit. It's a custom AI accelerator chip designed by Google specially to speed up machine learning workload, particular to massive metric calculation that happen inside the neural network. Unlike CPU and GPU, which is general purpose, a TPU does one thing and does it extremely fast. So the world innovated so fast. Now we are not able to understand properly GPU. Now the Google has launched the TPU because this is a competition market. So we need to understand whether key of innovation in the TPU. Why this Google thought that we need to do this? The key of innovation that the systolic array. The heart of TPU is matrix multiply unit. Build a systolic array, a grid of thousands of tiny multiply accumulate, which is called a MAC cell. Data flow through this grid like a wave, which each cell multiply two number and passing the result to its neighbor. This allows the TPU to perform an entire matrix manipulation in a single coordinate swipe. So, see each cell multiplying two numbers and passing the result to its neighbor so fast. So, TPU to perform entire multiplication in a single coordinate sweep without a repeatedly reading from memory. So Google TPU has 128 to 128 systolic array. That's 116,384 MAC, which we can say multiply accumulate operation happening simultaneously every clock cycle. So you guys think that this is how fast is TPU. Now people is not able to digest the GPU, but now we have another era which TPU is going to very common, and we will find the result technology is very fast. So guys, let's take one last slide and understand the difference between the CPU versus GPU versus TPU. So CPU, again, general task where we have core 4 to 64, strength is flexible but low latency, weakness is slow for AI. So we can't consider CPU for AI. Memory in system RAM used by everyone. This is basically belong to computer or old server. What is GPU? Graphical plus parallel. 1,000 minimum count, core count is 1,000. Parallel float. Journal overhead. Weakness is journal overhead. Memory is VRAM, where we can consider VRAM is GDDR forward slash HBM. Used by gamer AI developer. Now let's come to TPI. TPU, sorry. TPU is for neural network math. Neural network, the human mind is a neural, and that is a different level of concept where systolic array fixed, which we discussed, matrix multiplying AI training. Wow. Only good for machine learning. Machine learning. HBM very high bandwidth where it is used by Google AI internal cloud. So guys, this is the basic video for CPU, GPU and TPU. I hope you will get fair understanding of CPU, GPU. I will make more video. Thank you for watching this video and please subscribe my channel. Thank you.